How the universe will end. Musical note, low, deep atmospheric tone. There is one equation that determines the fate of everything. It does not describe stars. It does not describe galaxies. It describes expansion itself. It tells us that the rate at which the universe expands depends on three things. First, how much energy exists in the universe. Second, the shape of space itself. Third, something mysterious we call dark energy. Increase the energy density, expansion slows. Increase dark energy, expansion accelerates. Curve space positively, the universe can collapse. Make it flat, it expands forever. This is not philosophy. It is gravitational dynamics applied to the entire cosmos. Right now, measurements show something extraordinary. The expansion of the universe is accelerating. Not slowing. Accelerating. That single fact narrows the possible endings. But it does not eliminate danger. Snowflake heat death, the thermodynamic end. There is a law more powerful than gravity. The second law of thermodynamics. It says that in any closed system, disorder increases. But disorder is a misleading word. Entropy is not chaos. Entropy is the spreading of energy until it can no longer do work. Stars shine because energy flows from hotter regions to colder ones. Life exists because energy gradients exist. Remove gradients, and processes stop. In the far future, stars exhaust nuclear fuel. White dwarfs cool. Neutron stars decay. If protons are unstable, matter itself dissolves over unimaginable time. Black holes remain. But even black holes are not eternal. Quantum theory predicts that near the event horizon, particle-antiparticle pairs form. One falls in. One escapes. To an outside observer, the black hole loses mass. Over trillions upon trillions of years, even the largest black holes evaporate. And when the final black hole disappears, energy becomes evenly distributed. No temperature differences. No structure. No chemistry. The universe reaches thermodynamic equilibrium. Nothing dramatic. Just stillness. Cosmic exhaustion. Explosion symbol the Big Rip, when expansion wins absolutely. Dark energy behaves like pressure. And pressure affects gravity. If dark energy pressure is negative enough, it does not just oppose gravity. It overwhelms it. Right now, observations suggest dark energy behaves almost like a constant background energy of space. But if its pressure is more negative than current estimates, then expansion grows faster and faster. Not gradually. Exponentially. Eventually, expansion overcomes gravity holding galaxies together. Then the force binding solar systems. Then the electromagnetic force holding atoms together. When expansion becomes stronger than nuclear forces, even atomic nuclei disintegrate. Space-time itself stretches beyond cohesion. This is not an explosion. It is space-time being pulled apart from within. Current data suggests this is unlikely. But the mathematics allows it. And mathematics has no emotion. The big crunch, gravity strikes back. Imagine density slightly higher than we observe. If total energy density crosses a critical threshold, gravity wins. Expansion slows. Stops. Then reverses. Galaxies fall toward each other. Cosmic background radiation grows hotter. Eventually all structure collapses. Density rises without bound. Temperature increases toward infinity. The universe contracts into a singular state. Possibly ending in a bounce. Possibly ending permanently. But current measurements show space is nearly flat. Which makes collapse improbable. Not impossible. Just disfavored. Radioactivity symbol #vacuum decay, the silent catastrophe. Now we enter the most unsettling possibility. Quantum field theory tells us the universe is built from fields. The Higgs field determines particle masses. That field has an energy landscape. Imagine valleys separated by hills. We assume we sit in the lowest valley. But what if we do not? What if our vacuum state is only temporarily stable? Quantum mechanics allows tunneling. Even without enough energy to cross a barrier, systems can pass through it. If a lower energy vacuum exists, a tiny region could transition. That region would expand at light speed. Inside it, the strength of forces would change. Particle masses would change. Atoms would not hold. Chemistry would cease instantly. No warning. No signal ahead of it. Just a spherical wall of new physics expanding at the speed of light. Measurements of the Higgs mass suggest this scenario is mathematically possible. Not certain, but allowed. The universe may not die from expansion. It may die from quantum instability. The final era. No matter which path dominates, there is a common theme. Complexity disappears. Black holes outlive stars. Radiation outlives black holes. Entropy outlives structure. Eventually, energy spreads so evenly that no process can occur. No gradients. No flow. No events. The universe becomes a system with maximum entropy. And maximum entropy means no change. The strange beauty of this. Pause for a moment. A temporary biological organism, on a rock orbiting an ordinary star, has calculated the possible endings of reality. That is extraordinary. We may not survive cosmic time, but we have understood it. The universe will end. That is almost guaranteed. How? That remains open. And science lives in that uncertainty. Not by memorizing equations, but by asking, what controls expansion? Is vacuum stable? Does entropy always win? The future of the universe is not mystical. It is dynamic. It is mathematical. And it is still being solved. If this made you curious, you already know how to support us.